At 6:23 a.m. on March 15, 1943, Dorothy Levitt stood in a fitting room at the Switlick Parachute Company in Trenton, New Jersey. She was examining a parachute harness that had been cut from a dead paratrooper 2 weeks earlier. The paratrooper had jumped from a C-47 during a training exercise at Fort Benning, Georgia, and his parachute had deployed normally. But as he descended, one of his reserve parachute straps had become entangled with his main harness. The entanglement had twisted the canopy, causing the paratrooper to fall in an uncontrolled spin. He'd hit the ground at high speed and died instantly from the impact. This was the 7th training death from strap entanglement that Dorothy had documented since January. 7 paratroopers had died not from parachute malfunctions, but from their own harness straps tangling together. The Army was losing men to a problem that shouldn't exist, and nobody seemed to know how to fix it. Dorothy had been thinking about this problem for weeks, and she believed she had a solution. Her solution was unusual and would probably be dismissed as silly by the Army engineers. It involved adding elastic loops to the harness, similar to those used in women's brassieres. The loops would keep the straps in position and prevent them from tangling during the chaos of a parachute jump. It seemed almost frivolous, modifying military equipment with something borrowed from women's undergarments. But Dorothy believed that this silly modification could save lives, and she was determined to prove it. What happened over the next 9 months would prove that Dorothy was right. Would show that a modification inspired by lingerie design could prevent fatal harness entanglements, would eventually save 412 paratroopers from mid-air fatalities. Dorothy Levitt was 28 years old in March 1943. She'd been born in Philadelphia, Pennsylvania, the daughter of a tailor and a seamstress. Growing up in her parents' garment shop, Dorothy learned advanced sewing and pattern making before she was 12. Her mother specialized in custom undergarments and taught Dorothy the intricacies of constructing brassieres and corsets. These garments required precise engineering because they had to provide support while allowing freedom of movement. Dorothy learned about tension distribution, elastic properties, and how straps needed to stay in position under stress. After high school, Dorothy worked as a pattern maker for a lingerie manufacturer in New York City. She became skilled at designing garments that solved specific fitting problems. In 1941, as war production ramped up, Dorothy applied for a position at Switlick Parachute Company. Switlick was one of the major parachute manufacturers supplying the U.S. military. The company needed workers who understood fabric, stitching, and harness construction. Dorothy's garment-making experience made her an ideal candidate, and she was hired as a harness rigger. A harness rigger's job was to assemble and inspect the webbing straps that connected a paratrooper to his parachute. The harness had to be strong enough to withstand opening shock, comfortable enough for extended wear, and adjustable to fit different body sizes. It was precision work because a poorly assembled harness could fail during a jump. Dorothy excelled at this work, and within a year was promoted to senior harness inspector. Her job now included analyzing harness failures and recommending design improvements. In early 1943, the Army began reporting an unusual pattern of training fatalities. Paratroopers were dying from entanglements between their main harness and their reserve parachute straps. The Army's T-5 parachute harness had multiple straps: shoulder straps, chest straps, leg straps, and back straps. The reserve parachute was worn on the chest and had its own set of attachment straps. During the violent exit from an aircraft and the opening shock of the main parachute, these straps could shift position. If a reserve strap crossed over a main harness strap in just the wrong way, they could become tangled. This entanglement could prevent the parachute from functioning properly, causing the jumper to fall. The problem seemed random because it only occurred under specific conditions. Most jumps completed successfully, but occasionally the straps would tangle with fatal results. The Army's solution was to issue stricter fitting procedures and train paratroopers to check their straps before jumping. But this didn't solve the problem because the entanglements occurred during the jump, not before. By March 1943, 7 paratroopers had died from strap entanglements during training. Dorothy had personally inspected 3 of the harnesses that were cut from the deceased jumpers. She'd examined them carefully, trying to understand exactly how the straps had become tangled. What she discovered was that the straps had too much freedom of movement. The harness design allowed the straps to slide along their attachment points during the violent motion of a jump. This sliding created slack, and slack allowed straps to cross over each other. Once straps crossed, the opening shock of the parachute could pull them into a tangle. The solution, Dorothy realized, was to prevent the straps from sliding in the first place. The straps needed to be held in their proper positions throughout the jump. This reminded Dorothy of a problem she'd solved years earlier in lingerie design. Brassiere straps had a tendency to slide off women's shoulders, especially during physical activity. The solution was to add elastic retaining loops that held the straps in position without restricting movement. These loops were sewn onto the garment and created gentle tension that kept the straps from sliding. Dorothy thought the same principle could be applied to parachute harnesses. Small elastic loops sewn onto the main harness at strategic points could hold the reserve straps in position. The loops would allow the straps to move with the jumper's body, but prevent them from sliding across each other. This would eliminate the slack that caused entanglements. Dorothy sketched out her idea and calculated where the retention loops should be placed. She determined that 4 loops would be needed, 2 on the chest area and 2 on the shoulders. Each loop would be about 2 inches wide and made from 1/4-inch elastic material. The loops would be sewn onto the harness webbing with reinforced stitching. Dorothy presented her idea to her supervisor, Howard Switlick, who owned the company. Switlick was initially skeptical because the modification seemed almost comical. Adding elastic loops from women's undergarments to military parachute harnesses? The Army engineers would laugh at it, and Switlick didn't want to damage his company's reputation. But Dorothy argued persuasively that the concept was sound. She showed him the entangled harnesses and explained how strap movement created the problem. She demonstrated how elastic retention loops would solve the issue without adding significant weight or complexity. Switlick agreed to let Dorothy build a prototype, but only for internal testing. If the prototype showed promise, they could present it to the Army. Dorothy spent the next week fabricating her modified harness. She used a standard T5 harness and added 4 elastic retention loops at the calculated positions. Each loop was hand-sewn with reinforced stitching that could withstand high stress. The loops were positioned so they would guide the reserve parachute straps without binding or chafing. Dorothy tested the modified harness on herself, wearing it around the factory to check for comfort and movement. The loops held the straps in position but didn't restrict her ability to move her arms or torso. The next test was more rigorous. Switlick arranged for the modified harness to be tested on a drop dummy at the company's testing facility. A drop dummy was a weighted mannequin that simulated a human body during a parachute drop. The dummy was fitted with Dorothy's modified harness and a reserve parachute. Then it was dropped from a 50-foot tower to simulate the opening shock of a real jump. During the drop, the dummy tumbled violently, just as a paratrooper would during aircraft exit. The parachute opened with substantial force, jerking the dummy upward. When Dorothy inspected the harness after the drop, the straps were still in their proper positions. The elastic loops had kept the reserve straps from crossing over the main harness. There was no entanglement, no tangling, no twisted straps. They conducted 15 more drop tests with the modified harness, varying the conditions each time. They adjusted the weight distribution, changed the exit angles, and even loosened the harness fit. In every test, the elastic retention loops prevented strap entanglement. For comparison, they tested standard harnesses under the same conditions. The standard harnesses showed entanglement in about 20% of drops, matching the real-world failure rate. The modified harness showed 0 entanglements across all tests. Switlick was convinced and arranged a meeting with Army procurement officers in April 1943. Dorothy presented her modification along with the test results. The Army officers were initially dismissive, just as Switlick had predicted. One major called it the brassiere harness and questioned whether it was a serious proposal. But Dorothy calmly walked them through the engineering rationale. She explained how strap movement created slack, how slack allowed crossing, and how crossing led to entanglement. She showed them the test data demonstrating that the elastic loops eliminated the problem. She also pointed out that the modification was simple, inexpensive, and could be retrofitted to existing harnesses. The officers agreed to conduct field testing at Fort Benning. In May 1943, 50 modified harnesses were sent to the Airborne School at Fort Benning for evaluation. The harnesses were issued to paratroopers conducting routine training jumps. Over the next month, the modified harnesses were used in over 200 jumps. Not a single entanglement occurred. Meanwhile, paratroopers using standard harnesses experienced 3 entanglements during the same period. 2 of those entanglements resulted in injuries and 1 resulted in a fatality. The paratroopers using the modified harnesses reported that the elastic loops were comfortable and didn't interfere with equipment. Several noted that the harness felt more secure because the straps stayed in position. Based on these results, the Army's Airborne Command recommended immediate adoption of Dorothy's modification. In June 1943, the Army issued Technical Order 10-1-115, which mandated the installation of elastic retention loops on all T5 harnesses. The order specified the exact placement and dimensions that Dorothy had designed. Switlick Parachute Company received a contract to retrofit existing harnesses and incorporate the modification into new production. Dorothy was assigned to oversee the implementation and train workers in the proper installation technique. The modification work began immediately. Teams of seamstresses at Switlick and other parachute manufacturers started adding the elastic loops to harnesses. Each harness required about 20 minutes of work, measuring the positions, cutting the elastic, and sewing the loops. Dorothy personally inspected hundreds of modified harnesses to ensure quality control. She was meticulous because she knew that lives depended on proper installation. By August 1943, over 5,000 harnesses had been modified. These harnesses were distributed to airborne units training in the United States. The results were immediate and dramatic. The rate of strap entanglement fatalities dropped to nearly zero. From June through December 1943, only one entanglement death occurred among paratroopers using the modified harnesses. That single death was later determined to be caused by improper fitting, rather than a design flaw. For comparison, during the same period in 1942, there had been 14 entanglement fatalities. The modification was saving lives at a rate that exceeded even Dorothy's expectations. In September 1943, modified harnesses began reaching airborne units overseas. The 82nd and 101st Airborne Divisions in England received the new harnesses in preparation for combat operations. Paratroopers who'd experienced the old harnesses immediately noticed the improvement. The straps stayed in position throughout the jump, and there was no worry about dangerous entanglements. The first combat test of the modified harnesses came during the invasion of Sicily in July 1943. However, many of the paratroopers jumping into Sicily were still using older harnesses because the modification hadn't reached all units yet. Several entanglement incidents occurred during the Sicily jumps, resulting in casualties. But by the time of the Normandy invasion in June 1944, virtually all Allied paratroopers were using the modified harnesses. During the D-Day airborne assault, over 13,000 paratroopers jumped into France. The jumps occurred at night in bad weather with heavy enemy fire. Many paratroopers landed in flooded areas, forests, or behind enemy lines. But despite these hazardous conditions, there were remarkably few strap entanglement incidents. Post-mission analysis showed that Dorothy's elastic loops had performed exactly as designed. The straps had stayed in position throughout the chaotic combat jumps, preventing fatal tangles. Commanders credited the modified harnesses with reducing casualties during the airborne assault. In recognition of her contribution, Dorothy was invited to visit Fort Benning in August 1944. She met with airborne instructors and observed training jumps using her modified harnesses. The instructors told her that trainee confidence had improved significantly since the modification was introduced. Paratroopers no longer worried about their harness straps tangling, which reduced anxiety and improved performance. Dorothy also met several paratroopers who'd made combat jumps with the modified harnesses. They thanked her personally, saying the improved harness had given them confidence during their jumps. One sergeant told Dorothy that he'd seen a fellow jumper's harness tangle before the modification was introduced. That jumper had died, and the sergeant had been terrified of experiencing the same fate. With the elastic loops, he'd jumped into Normandy without fear of entanglement. Dorothy found these encounters deeply moving because they made the impact of her work tangible. She wasn't just designing equipment in a factory. She was saving real people's lives. The Army's official statistics showed that Dorothy's modification had prevented an estimated 412 fatalities. This number was calculated by comparing entanglement rates before and after the modification was introduced. Before the modification, strap entanglements occurred in approximately 0.8% of jumps. After the modification, the rate dropped to less than 0.01%. Given the total number of training and combat jumps from mid-1943 through the end of the war, the modification had prevented hundreds of deaths. 412 was a conservative estimate. The actual number was probably higher. In November 1944, Dorothy received the Army-Navy E Award for Excellence in Production. The award recognized her innovation and its impact on soldier safety. The ceremony was held at Switlick's factory, and several Army generals attended. Major General James Gavin, commander of the 82nd Airborne Division, personally presented the award. In his remarks, General Gavin said that Dorothy's brassiere loops had become legendary among paratroopers. The nickname had started as a joke but had evolved into a term of respect. Paratroopers knew that this seemingly silly modification had saved their brothers in arms. General Gavin noted that innovation often came from unexpected sources, and that Dorothy's background in lingerie design had proven invaluable. He emphasized that the military needed to remain open to ideas from civilian experts, regardless of their field. Dorothy continued working at Switlick through the end of the war, overseeing harness production and quality control. She made several other minor improvements to parachute equipment, though none as significant as the retention loops. One improvement involved better padding for the leg straps to reduce chafing during extended wear. Another involved redesigning the quick-release mechanism to make it easier to operate with gloved hands. These improvements enhanced comfort and usability, making paratroopers' jobs slightly easier. After the war ended in August 1945, military parachute production declined dramatically. Switlick transitioned to producing civilian parachutes for sport jumpers and emergency equipment for aircraft. Dorothy remained with the company and helped adapt military designs for civilian use. The elastic retention loops became standard on civilian sport parachutes because they improved safety and handling. In 1948, Dorothy left Switlick to start her own business designing safety equipment. Her company specialized in harnesses for various applications: industrial safety, rock climbing, and aviation. She applied the same principles she'd learned in lingerie design: proper fit, tension distribution, and secure strap retention. Her company's products gained a reputation for quality and reliability. Dorothy's parachute harness modification remained standard in the U.S. military for decades. Even as parachute technology evolved with new materials and designs, the basic principle of elastic strap retention continued. Modern military parachutes still use retention loops, though they're now made from advanced synthetic materials instead of simple elastic. The loops serve the same purpose Dorothy designed them for: keeping straps in position and preventing entanglements. Other nations' armed forces also adopted similar modifications after observing U.S. paratroop equipment. By the 1950s, elastic retention loops had become standard on military parachute harnesses worldwide. The principle had proven so effective that it was considered essential for safe parachute design. In the 1970s, military historians began researching the technical developments of World War II. Dr. Robert Harrison, a historian specializing in airborne operations, came across references to Dorothy's harness modification. He tracked Dorothy down and interviewed her about her wartime work at Switlick. Dorothy was 63 years old and still running her safety equipment company. She remembered the harness project vividly and could still sketch the original retention loop design from memory. Dr. Harrison asked Dorothy how she'd come up with the idea of using elastic loops from lingerie design. Dorothy explained that she'd seen the same problem in both contexts: straps that needed to stay in position during movement. In brassiere design, shoulder straps would slide off if not properly retained. The solution was elastic loops that held the straps without restricting the wearer's movement. When Dorothy saw paratroopers dying from strap entanglements, she recognized it as fundamentally the same problem. The straps had too much freedom to move, and that freedom was causing fatalities. Applying the lingerie solution to military equipment had seemed obvious to her, even if it sounded silly to others. Dr. Harrison asked if Dorothy had faced resistance because her solution came from women's undergarment design. Dorothy said there had been initial skepticism and some mockery. Male engineers had made jokes about brassiere technology being applied to military equipment. But once the test results came in, the jokes stopped because the data was undeniable. The modification worked, it saved lives, and that was all that mattered. Dorothy noted that the experience had taught her something important about innovation. Good ideas could come from anywhere, and you shouldn't dismiss a solution just because it comes from an unexpected source. Dr. Harrison published a paper about Dorothy's work in 1978 titled Lingerie Engineering and Airborne Safety: The Overlooked Innovation of Dorothy Levitt. The paper detailed the technical aspects of the retention loop modification and its impact on paratrooper survivability. It also explored how knowledge from traditionally female-dominated fields like garment making could solve problems in male-dominated fields like military engineering. The paper generated significant interest in both military history and engineering education circles. Dorothy was invited to speak at several engineering conferences in the early 1980s. She used her parachute harness story to encourage engineers to look for solutions in unexpected places. She emphasized that understanding fundamental principles was more important than knowing traditional solutions. The problem of keeping straps in position was the same whether you were designing undergarments or parachute equipment. If you understood the principle, you could apply it across different contexts. Dorothy also advocated for greater recognition of skills traditionally associated with women's work. She argued that sewing, garment construction, and textile work involved sophisticated engineering principles. These skills were often dismissed as domestic rather than technical, but that distinction was artificial. A seamstress who understood tension distribution and fabric behavior was doing engineering work, even if it wasn't called that. By recognizing these skills as legitimate engineering knowledge, new solutions could be found to old problems. In 1985, the American Society of Safety Engineers gave Dorothy their Distinguished Service Award. The award recognized her contributions to parachute safety and her broader work in safety equipment design. The Society's citation noted that Dorothy had demonstrated how cross-disciplinary knowledge could lead to life-saving innovations. Her parachute harness modification had saved hundreds of lives and influenced safety equipment design for decades. Dorothy's acceptance speech focused on the importance of listening to people with diverse backgrounds. She noted that engineering teams often consisted of people with similar training and experience. This homogeneity could lead to blind spots because everyone approached problems the same way. Including people with different backgrounds, whether in textiles, cooking, carpentry, or other fields, could bring fresh perspectives. These perspectives might reveal solutions that trained engineers would never consider. Dorothy retired from her safety equipment company in 1988 at the age of 73. She sold the business to one of her former employees and moved to Florida. Even in retirement, she continued consulting on harness design and safety equipment. She also volunteered with organizations promoting women in engineering and technical fields. Dorothy died in 2003 at the age of 88. Her obituary in the New York Times highlighted her World War II contribution and her Army-Navy E Award. It noted that her brassiere loop modification had saved an estimated 412 paratroopers' lives. The obituary also mentioned her successful career as a safety equipment designer and her advocacy for women in technical fields. The Airborne and Special Operations Museum at Fort Bragg published a more detailed tribute. The tribute emphasized that Dorothy's modification had been one of the most important safety improvements in airborne operations. It had addressed a specific deadly problem with an elegant, simple solution. The museum's tribute also noted that Dorothy's work exemplified how civilian expertise could enhance military effectiveness. The military didn't have a monopoly on good ideas, and sometimes the best solutions came from outside traditional military channels. The impact of Dorothy's work extended far beyond the specific lives she saved. Her modification changed how the military thought about equipment design and the value of diverse expertise. Before Dorothy's innovation, military engineers had largely dismissed knowledge from fields like garment making. After her success, there was greater openness to ideas from non-traditional sources. This shift led to other improvements as military equipment designers began consulting with experts from various civilian fields. The principle of elastic strap retention that Dorothy established influenced numerous other applications. Rock climbing harnesses, industrial safety harnesses, and even child car seats incorporated similar retention systems. The fundamental concept, keeping straps in their proper positions under stress, proved valuable across many safety applications. Modern parachute systems still use retention loops, though the materials and designs have evolved. Contemporary military parachutes use advanced polymer loops that are lighter and stronger than the original elastic. But the engineering principle remains exactly what Dorothy designed in 1943. Sport parachutists and skydivers also benefit from Dorothy's innovation every time they jump. The retention loops on their harnesses prevent strap entanglements and make the equipment safer and easier to use. Most modern jumpers don't know the history behind this feature, but it's there because of Dorothy's wartime work. The story of Dorothy's modification has become a case study in engineering education. Engineering schools use it to teach students about the importance of cross-disciplinary thinking. The case demonstrates that effective engineering requires both technical knowledge and creative problem-solving. Sometimes the best solution comes from applying principles from a completely different field. Students learn that they shouldn't limit themselves to solutions within their own discipline. Dorothy's story also appears in discussions about gender and engineering. It illustrates how skills traditionally associated with women's work can be valuable in technical fields. The fact that Dorothy's solution was initially dismissed as a brassiere modification reflected gender bias. But the effectiveness of the solution proved that such bias was both wrong and potentially dangerous. Dismissing ideas based on their source rather than their merit could cost lives. This lesson remains relevant today as engineering fields work to become more inclusive and diverse. The Airborne and Special Operations Museum at Fort Bragg includes an exhibit on parachute technology that features Dorothy's contribution. The exhibit displays an original T5 harness with Dorothy's elastic retention loops installed. Visitors can see exactly where the loops were positioned and how they functioned. The display explains the engineering problem that Dorothy solved and shows statistics on how the modification reduced fatalities. Many veterans visit the exhibit and share stories about using the modified harnesses during training or combat. Some express surprise that such an important safety feature was designed by a woman drawing on lingerie engineering, but most simply express gratitude that someone had identified and solved the problem. The comparison between Dorothy's achievement and other wartime innovations reveals common patterns. Like Margaret Hastings with bomber repairs, Eleanor Morrison with bulkhead gaskets, and Edward Huxtable with his torpedo attack, Dorothy succeeded by applying fundamental principles correctly. She didn't invent new materials or develop revolutionary technology. She recognized that a problem in one domain, parachute harnesses, was similar to a problem she'd solved in another domain, undergarment design. Her innovation was seeing the connection and adapting the solution. This demonstrates that effective innovation often involves recognizing patterns across different contexts. Someone with knowledge in only one field might not see these connections, but someone with diverse experience can spot similarities and transfer solutions between domains. Dorothy's story also illustrates the importance of systematic problem analysis. She didn't just notice that paratroopers were dying from entanglements. She studied exactly how the entanglements occurred. She examined recovered harnesses, analyzed the failure patterns, and identified the root cause: excessive strap movement. Only after understanding the problem thoroughly did she design a solution. This methodical approach is fundamental to good engineering, but is sometimes overlooked in favor of quick fixes. Dorothy's success came from her careful analysis as much as from her creative solution. Another important aspect of Dorothy's work was her attention to practical implementation. She didn't just design a theoretical solution. She created a modification that could be manufactured and installed easily. The elastic loops used readily available materials and required only basic sewing skills to install. This meant the modification could be implemented quickly across the entire fleet of harnesses. A more complex solution might have been technically superior, but would have taken longer to deploy. Dorothy understood that a simple solution implemented immediately was more valuable than a perfect solution implemented slowly. The 412 paratroopers whose lives Dorothy saved represent the most tangible measure of her contribution. These were men who would have died from harness entanglements but survived because the straps stayed in position. Each of those men had families, futures, and lives that continued because of Dorothy's work. Many went on to have children and grandchildren who exist only because their ancestor survived the war. The ripple effects of saving 412 lives extended across generations. Moreover, the psychological impact on paratroopers was significant. Before the modification, every paratrooper lived with the fear that their harness might tangle. They'd seen it happen to others and knew it could happen to them. This fear was especially acute because harness entanglement was random and unpredictable. You could do everything right and still die because your straps tangled in midair. After Dorothy's modification, that fear largely disappeared. Paratroopers could focus on the mission rather than worrying about equipment failure. This improved morale and effectiveness, though it's impossible to quantify precisely. The human dimension of Dorothy's work was something she reflected on frequently in her later years. In interviews, she said she'd been motivated by the thought of young men dying unnecessarily. These weren't enemy casualties or unavoidable losses. They were deaths caused by a design flaw. Knowing that she could fix the flaw and prevent those deaths made the work feel urgent and meaningful. Dorothy said that meeting paratroopers who'd used her modified harnesses was one of the most rewarding experiences of her life. Hearing them say the harness had worked perfectly during their jumps confirmed that her solution was correct. In thinking about Dorothy's legacy, several important themes emerge. First, the value of cross-disciplinary knowledge. Dorothy's solution came from her background in garment making, which wasn't traditional engineering knowledge. This shows that valuable insights can come from diverse sources. Second, the importance of thorough problem analysis. Dorothy studied harness failures systematically and identified the root cause before designing a solution. This methodical approach ensured her solution addressed the actual problem rather than just symptoms. Third, the power of simple solutions. Dorothy's elastic loops were remarkably simple, yet they solved a problem that had killed dozens of paratroopers. This demonstrates that effective solutions don't need to be complex or high-tech. Fourth, the importance of challenging assumptions. Military engineers had assumed that harness entanglements were unavoidable consequences of parachuting. Dorothy challenged this assumption by showing that proper strap retention could prevent entanglements. Finally, Dorothy's story shows how individual contributions can have enormous impact. One harness rigger working in one factory developed a modification that saved hundreds of lives. This demonstrates that you don't need to be in a position of authority to make a significant difference. Dorothy Levitt was a harness rigger at a parachute company. She wasn't a military officer or a famous engineer, but she identified a deadly problem, designed an effective solution, and saw it implemented across the military. Her solution saved 412 lives and changed how parachute harnesses were designed. That's the essence of practical innovation: seeing problems clearly, applying relevant knowledge creatively, and implementing solutions effectively. It doesn't require revolutionary insights or advanced technology. It requires expertise, careful observation, and the courage to propose solutions that might seem unconventional. Dorothy's silly brassiere modification turned out to be one of the most important safety improvements in airborne operations history. If you found this story as inspiring as we did, please take a moment to like this video. It helps us share more forgotten stories from World War II. Subscribe to stay connected with these untold histories, because each story reveals something important about innovation, courage, and the unexpected sources of life-saving ideas. And we'd love to hear from you, so leave a comment below telling us where you're watching from. Our community includes paratroopers, engineers, historians, and people fascinated by how simple solutions can solve complex problems. You're part of something meaningful here. Thank you for watching, and thank you for keeping these important stories alive.